All right, so here we go. We're going to wrap up our unit on solving systems of equations with this video right here. So far we've learned graphing, we've learned substitution, and we've started to learn elimination. We've learned just the basics of elimination. And this video is going to fill out the rest of that concept of elimination, and then that'll be it. So after this video, you'll be able to solve a system of equation using any method that you prefer. And again, I want to emphasize that for our class, when it comes time to take the quiz, there will be problems that are easiest to do with grafting, but you don't have to use graphing. There will be problems that will be easiest to use substitution, but you don't have to use substitution. And there will be problems that will be easiest to solve with elimination, but you don't have to use elimination. So once we finish this video, and you've had a chance to practice full-blown elimination problems, at that point, you'll want to take the time to think about which method do I like best, or do I feel confident with all of them such that I could do whichever method seems easiest for that particular problem? All right, so that'll be a choice that you will have to make on your own as you're working through practice problems. All right, with that said though, let's take a look at the rest of our discussion on elimination. Only one learning objective again for this video, simply be able to solve problems with elimination. Last time, if you remember the learning objective right here, it said solve simple systems with elimination. Now it says solve any system. And that does include recognizing when a system has no solution or when it has infinite solutions. Okay, so in the last video, we wrapped up our last video with these 5 steps for solving systems of equations. Okay, we said that we were going to start by multiplying equations as necessary so that one variable would have the same coefficient but with opposite signs. Then we would add the 2 equations together. When we do that, the result is this variable that has the same coefficient but opposite signs. That variable will cancel out. It'll be eliminated. Okay. Then with the part that's left, since it only has one variable in it, we'll be able to solve for that variable. And from that point forward, it's the same as substitution. Substitute it into one of the original equations. When you're done, you might want to check your answer. Okay, so that's our basic process. And I'm just going to leave that right here off to the side of the video so that we can reference that as we go through the example in this video. So we're going to take a look ideally at 3 examples. The first one that just works out fairly normal. We're going to say that we have a negative 3x minus 2y equal to negative 4. And we're going to have a 5x plus 6y equal to 4. Okay, well, in the last video, we talked about situations where both of the one of the variables had matching coefficients. Okay, so like if this is a 3 up here, if that was a 3 down there, we talked about that in the last video. Or if this was a 2 up here, then this was a 2 down here. We talked about how to handle that in the last video. Obviously, that's not the case in this. 3 and 5 don't match. 2 and 6 don't match. So what you will want to do is the same as what we talked about before. Multiply each equation as necessary so that you end up with a variable that has the same coefficient. Now, I'm going to show you the way I would do this one first. And then when we're done, we'll talk about some ways to help you decide which you should or what you should multiply by. But here's what I'm going to do. I recognize that if I multiply 2 times 3, the answer will be 6. And so I can multiply the top equation by a 3. It's already negative. This is already positive. So the signs are already opposites of each other. So if I just simply multiply this by a positive 3, I'll be good. Now, like I said in the last video, when you're first learning this, some students find it easier to say, I'm going to multiply this thing by 1 because they like to think about the fact that they're multiplying both equations. That's optional. You don't have to do that. Obviously, anytime you multiply by 1, nothing changes. Okay, but in the top, we're going to distribute this 3 to all the bits and pieces of that equation there. So a 3 times negative 3x gives me a negative 9x. A 3 times negative 2y gives me a negative 6y. And a 3 times negative 4 gives me a negative 12. In the bottom, Again, technically, you can think of this as multiplying by 1, and I would have to distribute. That's somewhat optional because when you multiply by 1, everything is exactly the same. So you totally don't have to write that if you don't want to. Just some students prefer to write it that way. Okay, so I've done step 1. I've multiplied each equation so that we end up with one variable with the same coefficient. Our y's both have a coefficient of 6, but they have opposite signs. This one's negative, this one's positive. Okay, so we've achieved that. Next thing is add the equations together. So I'm just going to put a plus sign right here, draw a line. We're going to add the equations together. Remember, when you get to this part, actually before you even multiply, I would, the very, very first step, if the parts don't line up, rearrange them so that your x's line up, your y's line up, your equal signs line up, your constants line up. Make sure everything lines up, because when you add stuff, you have to add like terms. And if not, everything is adding up. That's going to cause you problems. All right. Negative 9x plus a positive 5x is going to give me a negative 4x. The y's will cancel. There's my elimination step. Negative 12 plus positive 4 is a negative 8. So now I have added the equations, and just like should happen, one of the variables dropped out. That should always happen here. One of the variables should drop out. So now I solve for the variable that's left. So in this case, the variable that's left is x. In order to solve for x, I'm just going to divide both sides by negative 4. So when I divide by negative 4, these 4's cancel out. That leaves me with an x. Negative 8 divided by negative 4 is a positive 2. So now I have solved for the remaining variable. I know that x is equal to 2. The next thing we're going to do is substitute back into one of our original equations. Now remember, it doesn't matter what equation you plug it into as long as the equation has both x's and y's. So I usually go all the way back to one of the original equations. It would be acceptable for you to use one of these equations too, but I kind of feel like, why would you use equations that have bigger numbers when you could do something with smaller, more simple numbers, okay? It totally doesn't matter what equation you pick. So I personally, because I don't like negatives very much, I'm going to pick the bottom equation where everything is positive. The top equation is nice because all the numbers are small, but these numbers aren't too big and they're all positive. So I'm going to choose this equation. It's 100% up to you which equation you choose. It totally doesn't matter, as long as it's an equation that has x's and y's both in it. So now I can take this x equal to 2, and I can plug it in where x is. So that gives me a 5 times 2, when the x turns into a 2, plus 6y equals 4. And now I'm going to solve that equation. So I guess I didn't write that here in the last video. And solve. There we go. Now I'm going to solve that. So 5 times 2 is 10, plus 6y equals 4. I'm going to subtract 10 from both sides. That leaves me with a 6y equal to negative 6. When I divide both sides by 6, I end up with a y equal to negative 1. All right, so I now have my solution, my answer. I know the point. Remember, what we just found is the spot where the two lines are intersecting. I know where that is now. It's the point x is 2, y is negative 1, the point 2, negative 1. Okay, so that's the basic flow to these types of problems. Now, I said at the beginning that I wanted to talk a little bit about how do you know what to multiply by? How do you know what to multiply by? Okay, there's two pieces to this. One piece is just a little bit of mathematical insight. So if you remember, I said I was going to multiply by 3 because I recognized that 2 times 3 equals 6. And multiplying by 3 and multiplying by 1, those are pretty easy operations. So I chose that because it was going to be pretty easy math. I'm just multiplying by small numbers. And when I did that, my y's would match. So if you have a little bit of mathematical insight, then that's one way to help you choose. And there's a lot of different things I could say about that. But this video would get really long, and some of it would apply to you and some of it wouldn't apply to you. So I'm just going to leave it a little vague. Use a little bit of mathematical reasoning to help you figure that out. That's option number 1. But here's option number 2. In fact, for option number 2, I'm going to show you just another example on option number 2. If you're ever not sure, in fact, I'm going to leave a little bit of space here because I'm going to jot this down as a statement once we do option number 2. If you're ever not sure what you should multiply by, then this example is going to show us what you can do. So here's the equation we're going to solve. 4x plus 3y is equal, I lost my numbers. What is that equal to? 13. Okay, there we go. That's equal to 13. And then my second equation is 5x minus 7y is equal to negative 16. So there's my system. Now, it's not immediately obvious. Like before, on this problem, on the problem that we just did, where's the problem that we just did? Here's my paper. On the problem we just did, I recognized that 2 times 3 gave me 6. So I could see, oh, there's a number that I can multiply 2 by so that it equals 6. And that was nice and simple. This one, there's not something nice and simple like this, okay? So if you're ever in doubt, what to multiply by, then what you can do is use the coefficients from each equation. Okay. Now, I'm going to leave that. That's a little bit vague. That doesn't make quite sense. So let me show you what I mean by that on this example, and then we'll fill this out a little bit more so it makes a little bit more sense. Here's what I mean by that. This x has a 4 in front of it. This x has a 5 in front of it. If I multiply this equation by 5, and I multiply this equation by 4, because I'm taking the number that was in the opposite equation, that will guarantee that my x's will have the same coefficient. So that's what I mean by I say use the coefficient from each equation. So I'm taking the coefficient from the bottom equation and I'm multiplying it by the top. Okay, so AKA multiply the top equation by a coefficient from the bottom. Okay, that's what I just did. I took the coefficient from the bottom, I'm multiplying the top equation by that. And multiply the bottom equation by the coefficient in the top. Coefficient from the top. So that's what I did. I took this coefficient from the top, it's 4, I'm multiplying the bottom by 4. Okay. Now, the one last thing you want to make sure, remember, I don't just want the numbers to match, I also want them to have opposite signs. So right now, this 4 is positive and this 5 is positive. So if I multiply both by positives, I'm going to end up with a positive. I don't want to do that. I need to make one of them negative, and it doesn't matter which one. So I'm just going to make the top one negative. Okay. Now, pause there for just a second. Some of you might recognize the y's already had opposite signs. And you might be wondering, couldn't I just multiply the top by 7 and the bottom by 3? They already have opposite signs. If I multiply the top by bottom by 7, because that's the coefficient from the bottom, then these would match with the ones down here if I multiply the bottom by 3. So I'm using this exact same concept, but I'm doing it to the y's instead of the x's. Would that be legal to do? Absolutely, that would be legal to do. And so that's what I mean when I say, if you have some mathematical insights, it'll give you some ideas about what numbers you should pick. So on this problem, it actually probably would have been better to use 3 and 7. But I'm talking about right here, if you're ever in doubt, if you just don't have any idea what to multiply by, this method works. Take the number in front of this x, put it down here. Take the number in front of that x, put it up there. Make sure that they're going to end up, make sure there's at least one of these that's a negative sign. So they'll end up with opposite signs. And then that's it. That's all you've got to do. So let's multiply this out. I'm going to take a -5 and distribute it to all 3 parts of this equation. So -5 times 4 is a -20x. -5 times 3 is a -15y. And -5 times 13 is a -65. And now I'm going to distribute this +4 to all 3 bits in the bottom equation. So 5 times 4 gives me a +20x. These match and they have opposite signs. That's exactly what I was shooting for, so that's good. 4 times a -7y is a -28y. And 4 times a -16 is a -64. So now I have my x's with matching coefficients but opposite signs. So I'm done with step 1. I'm going to add the 2 equations together. If I've done step 1 correctly, when I add the 2 equations together, something should cancel out. And sure enough, the x's cancel out. -20x plus +20x, they cancel. -15 plus a -28y. When I add those together, let's see, 5 and 8 gives me 13. Carry the 1, -43y. -43y. And then over here, a -65 and a -64, when I add those, I'm going to get a -129. -129. So now I divide both sides by that -43. And that'll get my y all by itself. So y is equal to, I believe this works out to be 3. I believe that works out to be 3. Yes, I'm pretty sure that works out to be 3. So there we go. That's a nice number. Now, the number's got a little bit big. Grab your calculator if you need to, but it works out very nice. So now we have solved, we've added the equations, and we've solved the remaining variables. So we've done step 1 and we've done step 2. I'm sorry, this was step 1, step 2, and now we've also done step 3. We're on to step 4. We're going to plug that back into one of the original equations. Again, it would be okay to plug it into one of these, but the numbers are ginormous. Why would you do that? Let's go back to one of the original equations and plug it in. It doesn't matter which one you pick. I'm going to pick the one on the top because the numbers are fairly small and they're all positive. So to me, that seems like an easier equation to work with. You can pick the ones on the bottom too, that's fine. So I know that y is equal to 3. So I'm going to plug that 3 in for y. All the rest of the equation stays the same. 4x plus 3 times that stuff equals 13. And so now we simplify and solve. 4x plus 9 equals 13. We'll subtract 9 from both sides. 13 minus 9 is 4. So it looks like x is going to be equal to 1. So we've got our answer. The answer is that x is 1 and y is 3. And I haven't mentioned it in this video yet, so maybe it's worth mentioning right now. Don't forget that if you have any question about what you've done on this problem, you can always check your answer by taking these 2 numbers and plugging them into the original equations. But remember, when you check, you have to plug these numbers into both equations because it has to work in both of them for it to actually be an answer. All right, so that's our basic idea. I'm going to call this video good right there. I already have a video. You might be thinking or wondering yourself, well, what about problems that have no solution or infinite solutions? What about problems that have no solutions and infinite solutions? If I have to be able to do anything, what about problems that have no solutions or infinite solutions? Okay, so I'm just going to remind you of this because it's the same with elimination as it was in substitution. If you're doing your algebra, it doesn't matter if you're doing algebra based on substitution or based on elimination. but you do a bunch of algebra steps and you solve a problem and you end up with x equals some number, like the one we just did, we got x equals to 1. Okay, and then we did some more algebra and we got y equal to 3. If you do that, then that's where your answer is just a nice point. Okay, but it's also, so that was the same with substitution and elimination. It's just the algebra looked different. Okay, so whatever algebra you're doing, whether it's substitution or elimination, this is what's going to end up happening when you get down to this spot, right? Well, if you're doing this and you do a bunch of algebra and your variables all cancel out and you end up with something like 5 equal to 3. Remember, we said in the video on substitution, this is a statement that's never true. So if you end up with a statement that's never true, right? 5 never equals 3. That's not true. 5 does not ever equal 3. If you end up with a statement that's never true, that means the lines never touch. So this would be a no solution problem. So that's the same with substitution as it is with elimination. It's no different. The only different is the kind of algebra that's happening in this little bubble right here. That's the only thing that's different. But this is the same. If you end up with a statement that's never true, that means the lines never touch, so there's no solution. If you're doing your algebra and you end up with a spot where the statement is always true, 0 equals 0, or 3 equals 3, or whatever, okay, a statement that's always true, that means the lines are always touching, and so that means there are infinite solutions in that case. Okay, so that's the same substitution, elimination. It doesn't make any difference. The only thing that would be different between the two is the kind of algebra you're doing. Are you adding equations together to make variables cancel, or are you solving and substituting to make variables disappear? It doesn't matter which kind of algebra you do. If you end up with a spot like this, then there's infinite solutions. If you end up with a spot like this, there's no solutions. If you end up with spots like this, then there's a single solution, and it's going to be whatever that point is. All right, so I think that takes care of this video. I think we've covered everything that we need to cover. Thanks for watching. Have a good one.